We've been studying areas and two-dimensional shapes. Now we're going to move on to three-dimensional shapes, three-dimensional figures. Three-dimensional figures, as a name, are called polyhedron. A polyhedron is a solid with all flat surfaces that enclose a single region of space. As you'll notice here, I have a cube in front of you, and I want to tell you the pieces of them. As we talk about polyhedron, they have certain characteristics or certain names that go with certain pieces. As we look at the red cube on the left-hand side here, you'll notice all of the faces are colored red. So those are called faces. So the flat surfaces that make up each of the sides, as you might want to think of it, are actually called faces. Then the little line segments that connect or surround the faces, like picture frames, are actually called edges. So we have faces, edges, and lastly the corner points, which are exaggerated a bit here by the big red dots. Those are actually called vertex or vertices. We've learned that word before, so that one's not new. The new ones here are faces and edges. Next we have types of prisms. The first, as a definition, a prism is a polyhedron with two parallel faces, which we call bases. Next, we also can have a regular prism, which is a prism with regular polygons as bases. We'll talk about this a little bit more, but the key part to understand here is what a base is. A base is not the part of the object that it is sitting on. That does not necessarily have to be the base. A base is simply a face which is parallel to another face. As we look at the first triangular shaped polyhedron here, the bases would actually be the triangle on this end that is facing you and its partner on the other end that's away from you. Those two triangles are parallel to each other, therefore they're the bases. There are no other bases that are parallel on this object, therefore we only have the possibility of the two triangles. The name of this shape then takes it from its name of the base. The base is a triangle, so we call it a triangular prism. Prism meaning two parallel bases, and the triangular part comes from the fact that the bases are triangles. As we look at the next object, it is the one special object because actually it has multiple bases. The bases on this shape are a bunch of rectangles, therefore we call it a rectangular prism. And lastly, hopefully you can start to see where the bases come from. This piece, and this piece, and this piece, and this piece. Actually, none of those are bases. The bases would be the two objects that are parallel to each other, which in the case of this question or this object, it would be on the end that's towards you and on the end away from you. The two bases that are parallel to each other on this object have the shape of a pentagon. Therefore, we call it a pentagonal prism. When we name the polyhedron, we find the bases, the two objects that are parallel to each other, look at their shape, and that will tell us the name of the object. Next, we'll move on to a pyramid. A pyramid and a prism are extremely different. Prism has two parallel bases. A pyramid has all faces except one intersecting at one vertex. As we look at it, a pyramid comes to a point. Therefore, the one piece of the pyramid that doesn't touch that point would be considered the base. So we'll look at the middle one that's a little bit easier to see. The part that I'm shading in red here, that would be the base because it never ever makes it to the top and touches that point. We name that then by the base. The base is a rectangle, so guess what we're going to call it? If you thought a rectangular pyramid, you're correct. Now let's go back to that first one. The first one there, the triangle is a base. Every face on that is actually a triangle. However, the one that is not touching the top is the triangle on the bottom. Therefore, it's a triangular pyramid. Lastly, you'll notice that on the bottom there's a 5-sided figure, which is called a pentagon. The base is a pentagon in that shape, so it is a pentagonal pyramid. Naming of these is very familiar, or very similar to when we name a prism. The biggest difference is obviously we're using pyramid here instead of prism. Next, we need to understand a couple of terms, and that is first, what is a regular polyhedron? A regular polyhedron is a polyhedron with all faces that are regular and congruent. As you look at the shape, every face, every edge, everything about the shape is consistent. You can't have rectangles and triangles on a regular polyhedron. You can't mix two different shapes. It would have to all be squares, because squares are regular shapes. Or they'd all have to be equilateral triangles. We'll see some examples of these in a moment. And the Platonic solids. It's convex regular polyhedra, and these objects were named after a philosopher and mathematician called Plato. Here's your examples of your polyhedrons. We have a tetrahedron, which is made up of 4 congruent triangles, or 4 equilateral triangles. We have a hexahedron, which is another name for a cube. We have an octahedron, which has 8 triangles connected together. The dodecahedron, which has 12 pentagons hooked together. And we have the icosahedron, which has 20 faces, which are all made up by equilateral triangles. Let's see what these look like. Here's an icosahedron. Notice how all the faces have different colors, so it has 20 faces. But the thing I want you to notice here is just the fact that in these Platonic solids, every face is exactly the same. These are just some of our special regular polyhedrons. Here's our 4-sided, our tetrahedron. We have our 6-sided, which we often call the cube. We have our 8-sided. And finally the 12-sided. Those are just some examples of what they actually look like, and it gives you a little bit better visual. Back to our shapes. We have a group of shapes now that have a curved side to them. These 3 examples are not polyhedrons. They are not polyhedrons. It is the cylinder, the cone, and the sphere. The curved objects are not considered part of our polyhedron families. Cylinder is a 3D figure with parallel circular bases. Cone is a 3D figure with 1 circular base and 1 vertex. And lastly, the sphere is a set of all points in space equidistant from one point. Next, this one is somewhat challenging for people to understand, so if you don't understand this, please make sure to talk to us, because we would love to explain this a little bit better, as this is also something that you will see on your MCA test when you're in 11th grade. Cross-section. The cross-section of an object is the 2D shape that is created when a 3D shape is cut by a plane. The example that I like to use is if you're out in the woods and you take out a chainsaw and you cut a tree in half, what shape would you have when you're looking at the 2 pieces? So as you're looking at it, if you cut the log like I have here in the picture on the left, if you cut it directly across from side to side, straight across, so perpendicular to the actual tree, you would get a circle. Next, if you cut it diagonally from one side to the other, you would actually end up with more of an oval shape. And finally, if you cut it vertically straight down the tree, you're actually going to have a rectangular face. We're not saying the shape of the log that's left. We're just saying as the saw cuts through that object and you pick it up and look at it, that two-dimensional piece, so just the part that the saw cut through, as you looked at it, what shape is that? That is what's called a cross-section. Next we have orthogonal drawing. You'll notice there's a bunch of different topics here in this first section, and it kind of skips over all over the place. So just make sure you get your notes written down, and it'll be really helpful as we go through the rest of the chapter. Orthogonal drawings are simply the top, front, and side two-dimensional views of a three-dimensional object. 2D views are the top, left, front, and right sides of an object. Now we won't always see with these objects, you won't always see the left and right sides. Typically you'll see the front side, which we often refer to as the left, and you'll also see the right side, which is called just the side in a lot of different views. You'll see this if you take any kind of a CAD class. They will show you how to do two-dimensional drawings of our three-dimensional objects. Here we are. We have a corner view or a perspective view. View of the figure from a corner. So a corner view or the perspective view is the view of a figure from the corner. I have a picture on the right here of some cubes. What we're going to try and draw is we're going to try and draw the corner view of this stack of cubes. In order to draw these, you will have to have the right paper, so please make sure you come and get it from me when you need it for your homework. We're going to try and draw this stack of cubes that I have here on the paper I have in front of you. We always like to start at the frontmost edge. We don't want to look at it straight on. We actually want to pick a corner on the object, and that's the way we're going to look at it. As you look at the picture then, the two yellow cubes is where I'm going to start. So I'm going to just do one line down and another line down to represent the two cubes. From there we need to go diagonally. So I go back one for the bottom cube, the middle cube, and the top cube. So what I've drawn so far is the right-hand side of the yellow cube. Now if I connect these diagonally left, I'll have the left-hand side of the yellow cube. Finally, I need to connect it diagonally back off the top to get the top. So what I've just drawn is the corner view of the two yellow cubes. They're the only ones that we're actually going to see the two faces that are towards the front. For the red cubes now we're just going to continue middle and to the back, and notice you just keep going at that same parallel line. The red cubes again are two cubes tall. Then we go back at the angle to the right and then connect it back up to the blue. So now we've completed the red cubes. Now let's do the blue cubes on the right. To do that, notice it's 3 tall. We need to connect that back 1, and then we need to go up 1, 2, 3. Connect it across and up and back. Now as you'll do this, make sure you're doing this in pencil, because it's really easy to put a line in the wrong spot, but you'll see it after a couple little drawings. You're going to notice that you're a little bit out of order, not in the right spots. You'll want to change that up and fix it. Lastly, we have the green. So now we just have a stack of one green cube in the back here, and we're done. We've done our drawing. Next we're going to do the orthogonal drawings from the top, front, left, and right sides of the cube stacks. As we look at our shape, the front side of our stack of cubes is actually right there. The right side would be around the corner over here where I put the red dot, and the left side would actually be on the back, way back over here. I'll put a blue dot back there for left. So the left is back there, the right is on the front, to the right of the front, and then we have the front, obviously. As we look for the top view, let's start with the top view. As you look at the top view, imagine yourself standing in front of the cubes and then walking up the front and then looking straight down at the object. So that's what we're going to try and draw. As I look straight down, I would see one cube, on the left. So this would be the red cube that I'm drawing. Next to that, I would see the top of the yellow cube. On top, or to the top side of the yellow cube, would be the blue cube. And to the top side of that would be the green cube. So there would be an orthogonal front view. So we'll put an F here for front. Or excuse me, top. I was doing top, not front. So there's our top view. I apologize, I think I said front. So there's our top view. Next, let's do that front view. So now imagine you're standing facing that stack of cubes, and what would you see? You would see a 2 by 2. So let's do the 2 red cubes. There's the 2 by 2 for the red. Then we would see another 2 by 2 for the yellow. But now we have a problem. We would still see this blue cube that's up here above the yellow, but the way I have it drawn right now, it really looks like the blue cube, or excuse me, the stack of yellow cubes is actually 3 tall. That's not correct. So what we need to do is we actually need to make this line that would represent the top of the green cube to be a little thicker. So we have the 3 cubes, which would be the blue cubes, set off behind. So let's take a look at this. What would we have here? This cube would be for red, this cube would be for red, this one for yellow, this one for yellow, and finally this one for blue. But we needed to put that thick line in there because we needed to demonstrate the fact that that yellow cube is not actually having the blue cube sit directly on top of it. If you're not sure how this works, please just talk to me in class and I'll gladly show you. Next, let's do the view from the right side. The view from the right side, I have a stack of 2 yellow, then 3 blue, then 1 green. So I have 2 yellow, 3 blue, and then 1 green. And there we go. The last view we have is the left view. This one you actually kind of got to imagine yourself walking around the stack of cubes to the back side where my L is located and looking back at it. Well, the first thing we're going to see is we're going to see the 2 stacks of right cubes on the right. In the middle we'll see 3 blue, and on the left we're going to see 1 green. But notice the red ones are actually pulled forward in front of the blue. So we're going to have to draw that in our picture somehow. So we're going to have a 1, then a 3, and then a 2 for our cubes. We can draw that first. As we look from the back, that's what we should see. However, we need to realize that the blue cubes are not directly next to the red cubes. So what we're going to do is we're just going to make this line, if you can see it on the picture, a little thicker. I'm exaggerating it quite a bit so that you can see it on the YouTube videos. It doesn't need to be that thick. It just needs to be darker or thicker so that it's obvious that it's not, those two cubes are not actually touching each other. Hopefully you followed along with this, took some good notes. If you have any questions, please bring them back to class and I'll help you out with anything you had a problem with. That's the end.